All right, AP Chem. If you missed the office hour, this is the problem for today, May 12th. Go to the link and give yourself 18 minutes to finish this question and then come back for your answers. So this problem asks you about your order of reaction. So you're doing rate laws here and you're figuring out, are we first order, second order, or zero order for each of these? And this is the method of initial rates. And you'll know that it says initial rates on it, but just to remind you what that method is, they set up the experiment and they'll have a known concentration of iodine, no concentration of ClO minus in a container. They'll mix them together, and at the instant they mix them together, they'll figure out the rate of the chemical reaction, how fast it's occurring, and they'll record that rate here. And so if you look at our overall chemical reaction up here, what they're actually doing is they're measuring how fast one of these is produced, most likely in your chemical reaction. That's what's given as an answer over here. Now, why do they use the initial rate? Maybe you have a question like this on a test. The initial rate is used because as your concentration of iodine and chlorine go down, as these decrease, I'll do a little down arrow here, these increase. And what happens is, if you're not measuring the initial rate of the reaction, as we get some product formed over here, we start to get reverse reaction. And then the overall rate of reaction that can be measured in an experiment by measuring how fast one of these is produced is not accurately measuring the rate of the reaction because it's including the reverse and the forward rate, or basically the average of both of those. So what they do in an experiment is they say, let's only measure at the very beginning of the experiment. And then I know that I have absolutely no product in my container. And I know that I'm only measuring this direction for the rate of reaction. So I'm getting the actual rate of the chemical reaction as it depends on only the iodine and ClO minus concentrations, not any of the product concentrations. That's why you use an initial rate. And so for this, you probably remember how to do these problems, hopefully. You want to choose two different experiments where one of them doesn't change, so ClO minus does not change from experiment 1 to 2, but the iodine does. And we look and see what's the factor of change here. Well, we do 17 times 2 would be 34, times 3 would be 40, so we're at our 50, so this is about times 3, approximately. And you don't have to be perfect for that. Well, how do I get these two? Well, 15 times, or 0.156 times 3 is approximately our 0.476 here. So if I triple this side and I triple this side, then this is a first order. It's the same relationship on both sides. And the way to do that is to say, what do I have to raise this to? I have to raise this to the power 1 to get what my reactant multiplication was. So this is a first order with respect to iodine. We do the same thing for the ClO minus. We find two trials where the iodine doesn't change. That'd be trials 1 and 3. I'll switch colors here. So this is constant here, so it's not going to affect my rate of my reaction. But 15 to 61, what do we do to get to 60? Well, 15 times 4 gives me 60, so this would be quadrupled. And then I want to compare this trial to my final trial. What do I have to do here? You also have to quadruple it. So again, 4 raised to the first power. This is also a first order. So it's first order with respect to iodine and first order with respect to ClO minus. If it was second order, we would have had a 16 here, and we would have had to do 4 squared to get 16. Or if it was third order, we'd have a 64 here, and it'd be 4 to the third power. So that's how you get part A and B. The rate law is consistent with your calculations would be this: rate equals a K value times my concentration of iodine. Use square brackets. Make sure you put your charge, raised to the first power, times concentration of ClO minus, also raised to the first power. Oops. And then for part II, it asks you calculate the value for the K value. So I want to know what this is with the units, the correct units. So what do? You go back to your experiment, choose one of these. It doesn't matter which one of these I choose, but I need to choose one of them where I plug in my initial value, so I'll know my concentration for both these. And this is your rate. And so this is going to be on the left side here. You could choose any one of those trials. I'm not going to walk through the math there, but I just want to show you the unit. So if we follow our units through this problem, this is moles per liter and this is moles per liter. So we'd end up with moles per liter for the iodine and moles per liter for the ClO minus. And what do I want? For my rate, I need to have moles per liter per second. And so on this side, I need moles over liters times seconds. That equals, what's this arrow going to be? I have to have the correct unit for this to work out. Well, I need to cancel one of these moles per liter. So I'm going to cancel that with my units for K. I'll make those green here. So the first thing I'm going to do is liters over moles. that would cancel one of these, so this would go away, and I'd end up with moles per liter. And then I need seconds in the numerator, or in the denominator. So this would be my unit, moles per liter times seconds. And if you want to check your answer for your numbers, here's your numbers for that bottom one. And I'll walk through your points here. So moles per liters per second, 610 is your value. For points here, you get 1 point for A, saying it's first order. You could justify it and walk through their math here. We didn't do it this way in class, and you wouldn't have to do it that way on the test. You could do it like what we just did. For part II, you should get first order again, and you only get 1 point for that. For part B, if you write the rate law just like we did, you get 1 point. And then for part C, you get 1 point for the number and 1 point for these units, correct units. For our next part, you have a different chemical reaction given to you here for H2O2, breaking down to produce H2O and oxygen. The difference here with our data is we have time. And you don't have time on your first trial. So one of the ways to identify on a kinetics problem what approach am I going to use, there's no time in this table. This is the only time unit here, and it's just a unit for a measurement of a rate of change. So this is not actually measuring the amount of time that passes. It's just part of your number there. So this one's actually measuring the amount of time that passes. And so this would be the types of problems where you graph your concentration versus time and see if it's a straight line, and 1 over your concentration versus time to see if it's a straight line, and then your natural log of your concentration, which would be your first order, versus time to see if it's a straight line. And so that's what they ask you in this first part here. During the analysis of data, the graph below was produced and it gives you a straight line. Well, the problem tells you it's a first order reaction, and if it's a first order reaction, we would have this relationship right here. So you should have said natural log of concentration on your y-axis. What are the units for the rate constant K? Well, if it's a first order reaction, we're going to go back to this. Rate equals K times my concentration of H2O2 to the first power. Well, this will be in moles per liter. I want to end up with moles per liter times seconds over here. So my K value has to be, well, we already have moles per liter. We just want 1 over seconds. And that'll always be your K value for a first order reaction if it's an overall first order reaction. Our first one was first order with respect to both of the reactants, but the overall rate law was a second order. You add your powers for the overall rate law. And so we had a different unit there. So if we check their answer key here, for this one, this is how you got your points. You got a 1 point for, say, natural log of concentration. 1 over seconds or 1 over minutes would work either, 1 over time. And then the last part we didn't talk about yet. On the graph, you want to draw a line that represents the uncatalyzed. You should think slower. How do I get a slower reaction? Well, you have to have a lower rate K value. That's how you reduce your reaction rate. So if I go back to my rate law, if I want rate to change, this is not going to change. I might start with the same concentration. Maybe it's like a 0.3 molar solution of H2O2. If I want the rate to be slower, the K value has to change. What does the K value have to do with our graph here? Well, if you go back to your notes for this unit, you'll find this little graph in your note guide. It's the slope of this. And the slope of our line is a negative value. Remember, K values are always positive. So slope equals a negative K value here. So if I want my rate to slow down, which is what you want for a catalyzed reaction, I need my K value to be smaller. And if I make a smaller slope, then I'm going to have a slope. It's still going to start at the same point. We're still going to start at the same concentration. So natural log of my initial concentration would not change in this case. I'd still have 0.3 for both reactions. But for the uncatalyzed reaction, it's going to take longer for this to go down. So it's going to look something like this, where your slope is more shallow. And that's what they have on this little plot right here. Uncatalyzed reaction. You get 2 points for that, for all these features. Did you start in the same point? Your natural log of your initial concentration would be the same. Did you have a straight line and not a curved line? And did you have a smaller negative slope? You get 1 point if you only got 2 out of those 3, and you get no points if you only got 1 out of those 3. So if you want to compare it to the average, it's 4 out of 9 points on that problem. Hope that helps for a kinetics problem review. And I hope you're feeling ready for your test this week.